Alright, so before we get started on something new, let's just kind of recap what we've already done so far. Alright, so for right now, we're talking about right triangles. So the first thing is that we've got three different types of situations. The first two we've already looked at. The first situation, you would have to use Pythagorean theorem. The reason why you can use Pythagorean theorem in this example is because I'm asking you to find a side length. I'm asking you to find x. I gave you one side length and another side length. All right, so that means when I go in here, I can identify 13 as my hypotenuse, or my c value, and then 5 and x are my a and b value. All right, so that means I know that I'm going to do 5 squared plus x squared equals 13 squared. And then again, to solve the Pythagorean theorem, 5 squared is 25, so I have 25 plus x squared equals 169. I want to get x squared by itself, so I'm going to subtract 25 on both sides. And when you do that, you end up getting x squared equals 144. And then right here, to get x by itself, you have to take the square root. When you take the square root of both sides, you're going to get that x is equal to 12. So that means in this problem right here, my missing side length is 12. All right, our second situation is, again, I have a right triangle, and the question is asking you to find a side length. All right, so over here we could use Pythagorean theorem because we could set up a squared plus b squared equals c squared. But if you come over here, we have a problem. We can't do that because, yes, I did give you my hypotenuse, all right, but I only have one other side length. I didn't give you this side length here, so we can't use Pythagorean theorem. So that's when you have to go in and you have to use SOHCAHTOA. All right, so first, again, to figure out which trig function we're going to use, so am I going to use sine, am I going to use cosine, or am I going to use tangent? Well, we've already labeled our hypotenuse because it's always across from the right angle. All right, now we have to look at what angle we were given. So other than that 90-degree angle, I gave you 20 degrees. So this is the angle that we're referring to. All right, so after finding the hypotenuse, the easiest one is to find the opposite. So if I want to find the side opposite 20, 5 would be opposite 20. And then that would leave this leftover side to be adjacent. All right, but when I go in and try to figure out what trig function I'm going to use, you look at the information I gave you. I gave you the opposite side is 5, and I gave you that the hypotenuse is x. So if we're looking at using the opposite side for O and the hypotenuse for H, we have SOH. S is for sine, so that means we're going to use sine. So we say the sine, and the value we put there again is that angle. So the sine of 20 is equal to the opposite, which is 5, over the hypotenuse, which is x. First step you always have to do, again, is to multiply by the denominator to get that denominator out of there. So we're going to multiply both sides by x, and you get x times the sine of 20 is equal to 5. All right, now, this is just another algebra problem where you're trying to get x by itself. Well, what's attached to that x is sine of 20. So to get rid of the sine of 20, you're going to divide by the sine of 20 on both sides. So that means in your calculator, you're going to have to do 5 divided by the sine of 20, and close your parentheses. And you end up getting this long value. And when we do side lengths, we're going to go to 4 decimal places, which is the thousandth place. So x equals 14.6190. So that is what this side, or your hypotenuse, is equal to. All right, but now we have a third situation. All right, this one is we're going to be finding a missing angle in a right triangle. All right, whenever you're finding a missing angle, we're still going to use the whole idea of SOHCAHTOA, but now we're going to use what's called inverse trig. All right, so before we looked at sine, we looked at cosine, and we looked at tangent. Remember, those buttons are right here, sine, cosine, tangent. All right, but when I do inverse, the inverse is sine to the negative 1, cosine to the negative 1, and tangent to the negative 1. So if you look at your calculator, above sine in blue says sine to the negative 1, above cosine says cosine to the negative 1, and above tangent says tangent to the negative 1. So that means when I do inverse tangent, since all of those words are in blue, you're going to hit that blue second button first. All right, but let's take a look at an example of how I'm going to do this. All right, so first of all, when you look at this triangle right here, now I gave you two side lengths, but I'm trying to find an angle. I don't care what the hypotenuse is. All right, so the angle that we're referring to here is this x degree angle because that's what I want you to find. All right, so again, we're going to label all of the parts of our triangle. So across from the right angle is the hypotenuse. Then you look at the angle that we referred to. And the side opposite that x degree angle is 5. So this is my opposite, which makes this one my adjacent. All right, so now we look at the information that the problem gave us. So we have that the opposite is 5 and 7 is the adjacent. So when we look at SOHCAHTOA, we have O and A. And if you see here's O and here's A, and that goes with tangent. All right, so what we know about tangent is that the tangent of this angle x is equal to the opposite over the adjacent. All right, well, in this problem, we have that the tangent of x is equal to the opposite, which is 5, over the adjacent, which is 7. All right, now, in order to solve for x, the way you break up tangent in x is you do the inverse tangent. So to get tangent to the other side, we're going to say x equals tangent to the -1 of 5 over 7. So what happened is this x stayed on the left side. You don't divide by the word tangent. You do inverse tangent of that value that's still there. So now in your calculator, you're going to enter in the inverse tangent of 5 over 7. So again, the inverse is in blue, so we're going to hit second tangent. And now you see it says tangent to the -1. And then in parentheses, we're going to put exactly what this value is, which is 5 divided by 7. Close your parentheses, and you get your angle. Now, when we do angles, we're going to go to the nearest tenth for angles. So sides are 4 places, angles are 1 place. So that means x is 35.5 degrees. So this angle is 35.5 degrees. All right, let's take a look at another example. All right, again, in this example, I'm giving you this angle x. All right, so first we're going to identify the hypotenuse. Across from the right angle is your hypotenuse. Using this angle x over here is the opposite side, which leaves this 9 to be the adjacent side. So when you look at the information that I gave you this 9, which is the adjacent, and this 25, which is the hypotenuse. All right, so now when we want to figure out what trig function we're going to use, I gave you A and H is right here with C, so that means we're going to be using cosine. So to set up this problem, we're going to say cosine of this angle, which is x, equals, we're doing adjacent over the hypotenuse. So that means that the cosine of x is equal to the adjacent, which is 9, and the hypotenuse, which is 25. All right, now again, since we're solving for x, which is an angle, we have to get rid of this cosine and we have to take it to the other side. The way you take cosine to the other side is you do the inverse. So we're going to have x equals the inverse cosine of 9 over 25. All right, so now at this step right here, all I'm going to do is inverse cosine of 9 over 25 and put it in my calculator. So again, that means I'm going to hit second cosine, 9 divided by 25. Close your parentheses and hit enter. And so we're going to take this angle measure and round it to the nearest tenth, which is 68.89. Therefore, it's going to be 68.9 degrees. All right, so what I want you guys to do now is to finish the rest of this worksheet on your own.